Hello, my name is Simon Goldberg and I am a Blockchain Web3 Specialist Solutions Architect at AWS. In this video, we are going to explore an open source solution that allows you to access and analyze data from both Bitcoin and Ethereum. As the Web3 space continues to grow, a great amount of data is being written on-chain, and it can pose a challenge to perform an analysis on it. This is where the AWS Public Blockchain datasets come in, as they act as a mechanism to allow you to simply consume the underlying data and gain insights. I will now go over the architecture of the AWS Public Blockchain data solution. I will additionally show you how to deploy the required infrastructure to consume the data from your own AWS account. Before we dive any deeper, I first wanted to share some references with you in case you wanted to follow along. The first link is for the GitHub repository that has the full source code of the solution that I'm about to go over. I have also linked a complimentary blog post that contains a few sample queries and additional information about the solution. As a disclaimer, the AWS Public Blockchain datasets are experimental and they are not recommended for production use cases. For the Ethereum and Bitcoin datasets, we deployed an architecture to extract, transform, and load blockchain data into a column-oriented storage format that allows for easy access and expedited analysis. The following architecture diagram shows which AWS services are used on the producer account to extract the data from the public blockchains and how it is delivered to the public S3 bucket, such that it can be consumed by a consumer account. After taking an initial download of the full blockchain from the first block in 2009 for Bitcoin, ending 2015 for Ethereum, an on-chain listener continuously delivers new data to the public Amazon S3 bucket that provides the open datasets. Let's dive deeper into how this functions. The producer account employs two Amazon Elastic Container Service tasks, one for Ethereum and one for Bitcoin, which serve as a feed. These feeds continuously monitor their respective public blockchains, listening for new blocks. For Bitcoin, the solution utilizes Amazon Managed Blockchain Access, while for Ethereum, it uses a self-hosted Aragon Lighthouse node. This is because the Ethereum feed requires a node that supports batch APIs, which is not currently available on AMB Access Ethereum. Whenever a new block is detected, the feeds will publish a message to an Amazon Simple Notification Service topic. The topic then triggers the delivery of the message to an Amazon Simple Queue Service queue. Another set of ECS tasks then pull the queue, retrieving the messages that contain the new block data. These worker tasks are responsible for the actual extraction and processing of the blockchain data. Once a message is received from the queue, the worker task uses the appropriate JSON RPC APIs to retrieve the full block details, including the individual transactions. The worker task then parses and transforms the raw blockchain data, extracting key information such as transaction inputs, outputs, fees, and other relevant metrics. This processed data is then saved as partition Parquet files in the Amazon S3 public bucket. This allows for you to consume the data in an efficient manner for your analysis purposes using various big data tools and frameworks. Let's now zoom into the architecture of the consumer account. This is all the infrastructure you have to deploy in order to perform queries on the underlying datasets. There is a CloudFormation template that I will show you how to deploy that sets up an AWS data catalog, an Athena workgroup with an S3 bucket for query results, and an AWS Lambda function to keep partitions of the data up to date. By default, the link below the diagram will deploy the stack to US East 2 where the public S3 bucket is located. If you only use Athena to query the data, you can deploy it also in another region as Athena supports cross-region access. If you want to use Redshift, you need to deploy it to US East 2 as Redshift Spectrum doesn't support cross-region access currently. Let's now go over the database schemas for both the Ethereum and Bitcoin datasets. If you would like to see the schemas in more detail, they are included in the GitHub repository that I linked on the references slide just a few minutes ago. The following folder structure is currently provided for Ethereum data in the public S3 bucket. This dataset contains information about blocks, transactions, logs, token transfers, traces, and contracts. This folder structure is also provided for Bitcoin data. It contains extensive information about every single block and every individual transaction. I will now show you how to deploy the CloudFormation template into your own AWS account such that you are able to consume the underlying data. I will also go over several sample queries to showcase the power of the insights that can be gained. To consume the blockchain data in your own AWS account, navigate to the link that I shared on the previous slide below the consumer architecture diagram. This will take you to the CloudFormation console. The link of the template has been pre-populated, as you can see. I don't have to change any of the default settings, so I just have to scroll down and click next a few times. When I get to the last page, scroll all the way down and acknowledge that CloudFormation might create IAM resources and click submit. It'll take just a few minutes for this infrastructure to be deployed to your own account. Once your CloudFormation template has been deployed, navigate to Amazon Athena and launch the query editor. Before you can run a query, you first need to choose an S3 bucket for your query results to be stored. I can click the Edit Settings button and choose the bucket that was automatically created from the CloudFormation template that we just deployed. I can then click Save. At this point, I'm able to go to the query editor and write a sample query. I'm going to select one block from Bitcoin to see if it works. As you can see, information about a single block has been returned. I can also try this for the Bitcoin transactions table. As you can see, information about a single transaction has been returned. I can also write sample queries for Ethereum as well to test it out. As a note, it may take a few minutes for the data to be propagated into your Amazon Athena data catalog. So if you don't see any results at first, just wait a couple minutes and try again. I now want to go over a few advanced queries to showcase the insights that can be gained from analyzing the underlying blockchain data. Feel free to pause the video at any time if you would like to run one of these queries on your own. This first query selects the average Bitcoin block size in bytes along with the average transaction fee for every day since Bitcoin's inception in 2009. This would be very good time series data to graph to really see how the block size has increased along with the average transaction fee since 2009. I have a query here that gets the daily gas usage on Ethereum, and it can be used as a way to see how the network has increased in popularity over time. As more people are using the network, more gas fees are being paid, and the gas fees can get super high, and you can identify any outliers for when this occurred. This is personally my favorite query. It retrieves the largest Bitcoin transactions that have ever occurred. As you can see, the largest transaction ever took place on November 16th, 2011, with 550,000 Bitcoin transferred. I also have a query that gets the Bitcoin difficulty over time, and you can really see how this difficulty has increased since its inception in 2009 as more miners have joined the network. I will now show you this final query that retrieves the Bitcoin balance for a given address. As you can see, this wallet has a balance of 0.169 Bitcoin. I just wanted to point out that the runtime to retrieve this information was almost 40 seconds, which is quite a high latency, and I had to scan 1.15 terabytes of data. Amazon Athena prices at $5 per terabyte of data scanned, so not only was this high latency, but it also cost about $6 to get balance information for a single address. I will come back to this example at the end of the video to show you how you can retrieve balance information in a low latency and cost efficient manner. To provide an example of gaining deeper insights from the Bitcoin and Ethereum data, I created a visualization using a simple Python script. The script utilized the Bitcoin difficulty data to generate a clear and informative chart by utilizing the matplotlib and seaborn libraries. This allows us to better understand the trends and patterns in the Bitcoin network's mining difficulty over time. I would now like to return to the example where we retrieve Bitcoin balance information for a specific wallet address using Athena. That query took 40 seconds to run, and we had to scan 1.2 terabytes of data. If you were fetching balance information for a wallet application, this would not be an ideal user experience. I would like to introduce Amazon Managed Blockchain Query. It gives you serverless access to standardized multi-blockchain datasets with developer-friendly APIs. You can use AMB Query to quickly ship applications that require data from one or more public blockchains without the overhead of parsing the data, tracing smart contracts, or maintaining specialized indexing infrastructure. Whether you're analyzing historical token balances, viewing the transaction history for a given wallet address, or performing data analytics on the distribution of native currencies such as Ethereum, AMB Query makes the blockchain data accessible. AMB Query currently has support for both Bitcoin and Ethereum. It allows you to query native balances, transaction history, and more. I will now go over a quick demo of AMB Query to showcase its capabilities for quickly and easily retrieving blockchain data. I am doing this in the console, but you can also utilize AMB Query through various AWS SDKs. If you would like to experiment as well, navigate to the Amazon Managed Blockchain service on your AWS console, select Query Public Blockchains, and launch AMB Query. For my blockchain network, I will choose Bitcoin mainnet, and I will perform the Get Token Balance API operation. I will use the same Bitcoin address that I used in the Athena example previously. When I run this query, I get the balance for this address in just a few milliseconds. This is drastically more efficient than utilizing Athena to query for either balance or transactional history information. In conclusion, the AWS Public Blockchain datasets for Bitcoin and Ethereum provide a convenient way to access and analyze blockchain data. These datasets allow you to easily consume and gain insights related to cryptocurrency transactions, blocks, and other on-chain activity through advanced SQL queries. To further enhance the capabilities of these datasets, you can leverage AMB Query. AMB Query enables efficient querying of transaction histories, account balances, and more. By combining the AWS datasets with AMB Query, you can gain comprehensive insights into cryptocurrency networks in a low latency and cost-effective manner. Overall, this combination creates a robust solution for studying and deriving value from blockchain data. That is all for today's video. Thank you very much for joining me in this exploration of the AWS Public Blockchain datasets for both Bitcoin and Ethereum. Now that you are familiar with this solution, you are ready to gain insights from analyzing activity that has taken place on these networks. If you would like to learn more about this solution, please refer to the link in the description. Happy development!